So now let's look at what loop unrolling gives us. The first benefit it gives us is that it reduces the overall number of instructions we have to execute. We started out with this code, and the overall number of instructions that we execute in 1,000 iterations that we had of this loop, and the number of instructions that we had to execute in this loop was 5 instructions in each iteration times 1,000 iterations of the loop, for a total of 5,000 instructions to do this loop. Now we unrolled this loop once and got this. Now the number of instructions is 8 times. In each iteration of this loop, we are doing the work of 2 iterations, and we are moving the pointer by 2 places. So we will only have 500 iterations as opposed to 1,000 here, which gives us only 4,000 instructions to do the loop instead of 5,000. So we have dramatically reduced the number of instructions it takes to do the loop. And we did it by eliminating what's called the looping overhead. Basically, this is the work of the iteration, and this is the looping overhead to go to the next iteration. When we do 2 iterations at a time, we do twice the work, but the overhead only applies to one of the new iterations, so we get half the overhead per original iteration. Remember the iron law, where the execution time is the number of instructions times the CPI times the cycle time of the processor. The cycle time will not change. We still have the same processor. The CPI may or may not change, but definitely we have reduced the number of instructions. So we can see that loop unrolling, just by eliminating the looping overhead, can reduce the execution time. But let's look what happens to the CPI.